Welcome back, everyone, to day 3 of the Kaggle and Google 5 Days of AI Agents intensive course. I'm Smitha Kolan, Senior Developer Relations Engineer here at Google Cloud, and I'm here again with Anant Navalgaria. Anant, welcome back.
Thanks, Smitha. Hi, everyone. Welcome back. I'm Anant, the founder of this course and an evangelist and product manager at Cloud. Take it away, Smitha.
Good to see everyone here again. Drop in the chat what actually really surprised you the most from day 2. I'm also curious if anyone went down the rabbit hole on the managed MCP servers after yesterday's session. Let's start off with a quick overview for anyone new who's joining us today. So throughout the week, you're going to be getting white papers, companion podcasts, hands-on code labs, daily live streams and AMAs just like this one, and also an optional capstone project at the very end where you can compete for Kaggle certificates, badges, swag, and recognition across Kaggle and Google's social channels. So if you've registered, the content will actually land directly in your inbox. If not, everything is going to be on the Kaggle's learner portal, and also it will be announced in Discord. Also, huge shout out to all the people who put everything together, the Google researchers, the engineers who wrote the white papers, the speakers joining us this week, and also the Discord moderators who have been answering questions nonstop. With that said, let's actually get into an overview of day 3. So day 3, right? Yesterday was about how agents actually reach outwards, tools, other agents, payments. However, today is the opposite direction. How can an agent actually manage what it knows without falling apart as you ask it to do more? So the problem is probably one you've already hit. The obvious way to make an agent more capable is to keep adding to the system prompt. More instructions, more examples, more tools. It works for a while and then it stops. The agent will pick the wrong tool, maybe forget earlier instructions, or even start hallucinating. So the white paper today calls this context rot. And then it goes really in depth into how you can avoid stuff like that, right? And the answer the paper actually proposes is something called agent skills. So the format itself is really simple. It's just a folder with a markdown file called skill.md plus optional scripts and reference files. That's it. The clever part is actually the progressive disclosure. The agent only sees a tiny bit of the metadata for each skill at startup. So maybe 50 tokens. And then the full instruction only loads when the task actually matches. So you can have 50 or even 100 skills installed and still keep that context really lean. That's also why this format spread is really fast and it's not locked to any vendor in particular. The same skill actually works across multiple different IDEs, Anti-Gravity, Claude Code, ADK, any sort of other agentic tools. Basically anything that supports that standard. With that said, Anant, do you want to walk us through the white paper in more detail?
Thank you, Smitha. So yes, everyone, welcome back to today's white paper overview, where we are focusing on agent skills, the core paradigm outlined in the white paper. So over the last 2 days, we looked at a lot in our 2 white papers, everything from redefining the software development lifecycle, and also exploring how open protocols like MCP and A2A, as well as the other protocols and interfaces that we discussed, like A2UI, connect models to tools and other remote agents, and a lot more as well. Well, in today's white paper, we're going to look at agent skills. So if MCP is the hands of your agent skills are the playbooks. In this white paper, we defined a new architecture primitive, a self-contained skill folder, as Smitha outlined, centered around a single skill.md file, accompanied by scripts, references, and assets. Now, we also highlighted the elegance of progressive disclosure, as Smitha highlighted as well, by loading only lightweight metadata initially and fetching detailed execution guidelines and scripts strictly on demand. We can give our agents dozens of capabilities without causing any of the context rot or blowing our token budget beyond what it is set to be. This pattern lets a single general-purpose agent dynamically flex into specialized roles, offering a highly maintainable alternative to complex multi-agent setups, which can be hard to maintain and trace. Now, but the question that often arises when we discuss this is, how do we actually prove that these skills work, right? I mean, sounds nice theoretically, but do we really not need multi-agents? So we also discussed the evaluation of skills, focusing on trigger failures, output errors, and tool trajectory analysis. In some ways, slightly aligned with how we eval multi-agent setups as well. We explore the differences between simple success rates and rigorous consistency metrics, such as pass at K. And then we also showcased Google's Agent CLI, which hopefully some of you had a chance to play around in the code labs, illustrating how you can scaffold, test, and deploy skills into the runtime environments. Finally, the last part of the conclusive part of the white paper, we entered the meta skills territory, looking at how agents can watch successful execution, traces, and autonomously write or optimize their own skills. So that's a summary of what we covered in the white paper. And we also have some incredible labs built, which my colleague Polong will be covering in the later part of the live streams. But let's move on to the guest Q&A of the Smita.
Awesome. Okay, let's get into the Q&A. We have some amazing guests today. We have Debanshu, Gabriella, Julia, as well as Tanvi. Thank you all for making the time. Anand, over to you for the first few questions.
Thank you. So the first question is for you, Gabriella and Julia. So as public registries for agent skills scale, what security and verification mechanisms are required to ensure imported skills are portable and safe across different model families for coding? We've seen a lot about security risks when we security injection risks and a lot over the news cycle. So what's your opinion on this?
Yeah, so I really love this question, and thank you to the person who asked it, because I do feel you. I feel like I'm drowning all the skills where they are appearing everywhere. And what is happening is like skills, the format is very portable by default. So it runs literally everywhere. But it seems like over the time, this runs everywhere quietly turn into runs safely anywhere. So think out there, like around 1,000 public skills, I've found out that roughly 1 out of 8 had critical vulnerabilities, like hard-coded secrets, phoning home, prompt injection, all of that talking to the body. So, but I want to think about what are the main 2 problems of this, because there are 2 problems wearing one single code. So the first one is an easy one, because a malicious script is malicious everywhere. So you handle it the way you handle any dependency. You scan it, you check for secrets, you check who published it, the provenance, etc. The second problem is a little bit more complex, because it's where this portability, this beauty of portability bites back. The same skill can be perfectly safe from one model, but it can be very dangerous on another model, because every model has a different backbone. Some models follow pushy instructions too eagerly. Some other models have different guardrails and stop it. So behavior doesn't travel the same way than text. And verification step is not on the skill only, but also on the model level that is using that skill. Now, what you can practically do today, and what we have seen organizations that we've been working with are adopting. So the first one is a registry approach. So similar to what Hermes adopt, every skill gets a trust tier. For instance, the built-in skills ships with the agent, it's like not audited. The official from the project's own catalog are also not audited. The trusted from publishers like Google, Anthropic, they are also trustable. But the community one, this long tail, is what gets scanned, checked, and even can get blocked. Another pattern organizations are adopting, and I think it's personally, it will make my life way easier if we all adopt this one. It's similar to what NVIDIA is doing, which I think around May 26th, they launched Verify Agent Skills. And basically, it has 3 pieces. It's the skill inspector, which is looking for code vulnerabilities, agent-specific prompt injections, cryptography, singing, knowing what changed after this skill was shipped. And the last one is the skill card, which is a machine-readable file that tells you who made it, what access has, what are the limitations. So the idea is very simple. It's like to trust the info that arrives with the skill. Like it's like not only having the skill, but like this artifact that makes you feel like this is like secure. And this is not like standardized today, but we are seeing this need and organizations approaching it a very good way. So I will leave you with one prediction. It's like the skill registries that will win are not the ones with the long listings, but are the ones who which treat evaluation suites and safety card as a first class shippable part of the skill itself. So, and I also want to make clear it like skills is part of the context engineering that the agent gets, right? So many of these things can be propagated to other things. So it's not something new, it's something that the model receives. So we can adopt also many things that we've been adopting ever since LLMs emerged. I will stop here, and I'm also curious to hear what you have to say, Julia.
Yeah, absolutely. Thanks, Gabriela. I think you did a great job covering a lot of the details. At the high level, I would say probably there's one unifying principle for me that I talk to all the organizations we work with about, which is don't ever let safety fully depend on the model or on the set of skills. You want to have capabilities and skills that are explicitly and host enforced, make instructions explicit rather than implied, and put hard guarantees that we're used to, like Gabriela said in the beginning, from sandboxing, scoping, permissions, egress control, etc., around the outside, so that you can also switch out different models and test them along the way, and make sure you're doing that before you publish them or before you kind of publish any agents or any skills live. So I think that is really the key thing at the end of the day, to treat this in many ways and with some of the principles that we had around classic software engineering, and leverage those around this area, and don't ever delegate it fully to the model and assume that it's going to go kind of down that path.
That's amazing. Thanks a lot, guys. I love both those perspectives, and this gave me the idea, like an app store for skills where everything is verified is definitely something verified across different models. That's definitely where I see something a must do in the community as well. In addition to the custom controls, which you mentioned that we have to put on our side, it's still good to know that something is secured and tested and there's no malicious prompt injection in there. Perfect. Amazing. Shall we move on to the second question? So this one is for you, Devanshu. How can file-based skill patterns, such as the skill.md, be leveraged to help future foundational models dynamically retrieve and follow multi-turn runbooks natively?
Thank you for that question, Anand. It's an excellent question. Now, there are 3 aspects to this. First, looking at how skills dynamically retrieve knowledge, we have to solve context drop. Feed an AI a massive manual today, and it ignores instructions that are buried in the middle. The skill.md pattern fixes this via something called progressive disclosure, acting as the AI's procedural memory. Instead of loading everything up front, the model keeps tiny metadata footprints in active memory, retrieving only the specific instructions it needs at the exact moment. Second, this is how they will follow multi-turn runbooks natively, using DAGs or directed acyclic graphs. Instead of accumulating an execution history in a single bloated prompt, the DAG controller handles handoffs by passing schema references between isolated nodes via a message bus. The model finishes step 1, flushes the old instructions to protect the attention capacity, and cleanly swaps in the new capability profile for step 2. Third, this structure will help future foundation models evolve through meta skills. Looking ahead, models will author and optimize their skills themselves by observing successful workflows to draft new runbooks. However, any assumption that this will be a fully autonomous thing right away is flawed. Anything an AI writes must start as a draft. Without human spot checking, a model might optimize for the wrong metrics and make the library worse.
Maybe I would like to add something here, because we've seen this pattern in the past. What happened is like some models at the beginning was using like tools like Google Search as external tools, as a part of the environment, right? Eventually we found out customers, organizations really using it, and they don't want to select this as a tool. So what happened in the newest versions of the models was like it was natively train this model, so when the user asked something, it was automatically like calling a tool, like in this case, for instance, Google Search. So I think we might think that this is still a research question, whether we want the same to happen to skills, that automatically the model is trained to also learn this, like call the skills by default, calling, okay, I have this set of things that I can use. And I think this is a research question, and this is very new, but it will come also how the people is using, how it's adopted. And we've seen this pattern before with tools.
Makes sense, yeah.
Awesome. With that said, I think we can move on to the next question.
All right. Perfect. All right. This question is for you, Tanvi. In complex multi-agent graphs, how can state passing across distributed skills be optimized without bloating the model's context window as a shared messaging bus?
Thank you, Anant. And I think Debanshu and Gabriela also touched on this question a little bit. I would like to share a story probably from a customer. So we were once shipping a graph of skills that was basically flawless in the demo. Everything works well, but it was silently being degraded in the production. So everyone said it must be the model, but it wasn't. So the problem was that the full output was taking, every node was taking the most context and sending it as a prompt to the next one. And by the fourth hop, basically, the model was rereading everything in the upstream, and the context rot really sets in, right? So the fix for this problem was that we moved the state of the prompt into a file bus. So move the entire state, so decouple the state, and basically the graph controller will own the state now and not the conversation. So execution history will be will stop accumulating anything inside the model now. So this was the one way which we solved this. And the second solution was pass self-references, not the values. So instead of sending the entire JSON payload of the information to the next node, we were passing the pointers instead to help with the reference of the information. And the third way was to protect the model's attention was by having heavy data sitting outside of the text input. And the context really stays small, and the model's capacity only looks into the reasoning of the preserved context. So these were the three ways that we actually fixed this. And the second kind of a second order benefit which we get out of this was that the system became debuggable, right? So the system was sitting on the disk. It was inspectable instead of like having somewhere there is a deep conversation in the fifth hop. The whole transition actually changed the setup. So in the end, like I would like to add that the context window is not really a database. So let's not add everything in there, and let the model pass the handle to the system, which can do a lot more than just an LLM context.
And in some ways, I think skills is just prompt engineering combined with dynamic loading. So all the best practices which apply to prompt engineering and dynamic loading of things, like only load what's necessary.
Yeah.
Make sure that the graph is defined to set the right decisions get made. All of that should be applied. Thanks a lot. And making things debuggable is especially important in non-deterministic systems. It's a lot of
And do you think, Tanvi, that we can summarize this like past pointers and not like data, like not context, just past pointers?
Exactly. Yes, that's the main point here. Yes.
I think a follow-up question to a lot of what Gabriela and Tanvi and also like Julia have been saying is, so imagine you have a lot of skills, right? But you have a question that maybe the user is trying to solve, a problem the user is trying to solve, and multiple skills can actually be used to solve this. There's no actual right answer. So how do you kind of test which path the agent should go down on? Or what's kind of the most accurate one if there's multiple skills which can help solve something?
I have a very, because I've been thinking a lot about this, guys. I feel like we are thinking and fixating too much on doing self-skill improvement. I don't believe on that. It should be a skill library improvement, because this is a very important problem. You can have two skills that they have very ambiguous description, that they are more or less doing the same, and they are colliding. And honestly, Tanvi is here. We both have faced that, and it was like horrible. So I will suggest this, you take it, don't consume all the skills. Like, know which skills you have for your project. Do optimization of the skills for your project at the library level, not only on the skill level, and have evaluation data. Like, I think we cannot address enough in all these 5 days how important is evaluation at every part. But I think if you have different skills, do not optimize at skill level. Optimize at the library of skills level.
So are you telling me that skill is not all you need?
Skill is all you need, but control, right? Like, I mean, like otherwise, like, I don't want to say a strong statement here, Julia. Over to you.
I was just going to say, I think that in reality, you have to think about it in terms of the whole system, right? In terms of the whole, all of the pieces, rather than just a single component within it. Because every time you're looking at just a sliver and a component, it can always collide with another piece, which is, I think, the thing that people are kind of calling out here. And I think that's really what it comes down to. We talked about this in the very, very, very early days of agents, when Patrick and I wrote the first version of this agents paper, where we went down the path of essentially every single time you pass something off, you're going to lose kind of some kind of you're going to probably get some kind of performance degradation, right? And so you want to look at this from an entire process, and then break it up into pieces, but then bring it back up into that entire process, because that's the only way you're really going to get a truly performance system out of whatever you're trying to leverage and build here.
I would add just one more point, is that yes, put it in the system, and also have a routing system of when and where we need which skill, and then route it towards that skill.
So it seems like even skill management is going to be a huge thing, or probably still already is.
Yeah, prompt management to skill management. All right, guys, let's move on.
I wonder if it'll just be skills, or actually go into something like tasks and things like that when you're describing the goal, rather than just the individual component and primitive level. But yeah, agree.
Perfect. Awesome. I'm glad this question was so deep. Let's move on to the.
All right. Thanks, Anand. Really great context in all of those answers. We're going to now head on to our first community question from Kimber Goldes. So at what scale does the token size of progressive disclosure metadata trigger context route? And is hierarchical routing emerging as a viable solution to manage it? Tanvi, on to you.
Thank you, Smita. This is exactly what we were just talking about, routing. And absolutely. So this is a major worry, and it's natural, right? So it's always on the metadata. So let's say 100 skills is only 5K tokens, for example. And if we do the math, then we are safe if we have 1,000, right? But the context route is not really in the tokens, but it is like a gradient, which will be a distractor for the catalog. So if you have a catalog of skills, then all of the others which look alike as the first one, then these are all distractors. So routing really breaks with, let's say, 100 skills and not a few thousand, for example. So the catch here is that the overlap is the issue, not the size. So everyone who is reaching for a semantic retrieval, they might look for trade-offs with misrouting for, let's say, it may happen silently with a recall problem. But what we are trying to fix here is emerging through hierarchical routing, right? So instead of having a flat list of everything, you have a router, pick top picks, and then give a capability profiling to your skill, and then only the top 10 or, for example, 15 skills are exposed to the metadata, right? And then always the context is bounded by the profile. So you don't need to send the entire library to the prompt. So that's how it can be solved through hierarchical routing. And in the end, like, I think how I would summarize this is the ROT isn't about how much you are actually loading. It's about how many skills are actually looking alike when you load them.
Yeah, that's perfect. That's actually exactly what we were discussing too. So this is a great question. On to the next one. We have from Pranit. When skills, MCP, and tool calls are all available, how do you design the boundary so that skills handle the know-how and MCP handles reach without overlap? Gabriela and Julia.
Yeah, let me get started. This is another philosophical question. So, and especially like a very system design question. The other day I was in the library and was like a book called Find Your Why or something like that. And that made me think every decision that you do today with the engines, you have to think why I'm making this decision. There are so many primitives today out there. And the interesting part is like you can do hacky ways. You can put like skills inside AgentsMD, or you can put a skill system prompt. So there are many things that you can do technically speaking, or like agents and MCP. So technically speaking, you can do all of that. But you need to ask yourself the question, why I'm doing this? What is a skill? What is the MCP? And in this context, specifically of what you say, you have to ask yourself the question, is this knowledge or if this is access? So access is anything that touches the outside world, databases, API for pulling car information, MCP job, this tool to access the weather, etc. Whereas knowledge is everything about how to think about the work, which tools to call, in what order, what to do with the results, what are the edge cases, what are the gotchas, what is the process to get this HR journey, etc. But what I want to make very clear is like what we've seen today across the organizations is like you can create these solutions or plugins like binding these 2, 3, or 4 different primitives, or you can like bind skills and connectors, MCPs, and sub-agents. So if you want to do this, you have to ask, what is the purpose of this? For the skill, what is the connector, and what are the sub-agents? So you can say, okay, the skill, I'm going to put how to write Ernix update, how to run a diligent analysis, etc. For the MCPs, I'm going to put like API for credits data, this database that I need to extract information, and the sub-agent will be the delegators. So I think the theory is very clear. What the boundary for the skill is like the sites, processes, gotchas, and the connector is the acting. So I think when you create this, you have to ask your question, why I'm doing this? What is the purpose of the skill? What is the purpose of the MCP? And have this clear separation of concerns. And you can build beautiful plugins. You can build beautiful solutions with clear separation of concerns. And it just gets elegant and easier to maintain, etc. So I think, Julia, do you want to add something?
Yeah, I'd love to. So I have a pretty maybe overly simplified framework of how I put these things together. But I think about each of these things as a layer that you're answering a different question with. Mm-hmm. So the tool should answer, what is the single action that can be performed? That means it's Verb that can do a stable contract like send a message, list files, et cetera, et cetera. MCP answers, what can I reach? It's kind of the, for lack of a better term, wiring that connects all the actions to a real external system. So you think about the connection logic, the authentication, data access, all of those kind of components. And then the skill is the how do I go about doing something? They are the know-how, they are the conditional logic, the right sequence of steps, your domain conventions, your soft policies. They have no actual capability in them in that sense. So I think what I've been telling a lot of people in this is, if you can do the following kind of quick test to see if you've drawn the line, that is usually a pretty good set of boundaries. At least we found that in the organizations that we've been working with. If you're able to delete a skills instructions and the model can still technically perform the action, even if it's clumsy, i.e. in the wrong order with missing edge cases, et cetera, then the boundary is pretty clean. But if deleting it removes the ability to do something, you've kind of leaked some of the capability pieces into the know-how, and you should push that down to the tool or the MCP server.
This is great. I think a lot of people have this question. Yesterday, we also got something similar on what's kind of the fine line between MCP and A2A. For skills in particular, do you have kind of a heuristic for when something that maybe started as a skill should actually get promoted into its own MCP tool? Has that ever, come up in use cases?
I think so. I would generally segregate that a skill, and the MCP is the connection, right? Is in oversimplified terms, the connection, and that's where I would kind of draw that boundary. It's the connectors that Gabriela referred to in her structure, in her analogy, and the skill is kind of that knowledge and know-how. And I think of the two of them used together in many senses. I would actually say a skill probably becomes an MCP when you need to add like the connection to an outside world for a specific skill or something along those lines.
Great.
Yeah, I mean, one thing I've seen is like if you like have SOPs or something, some people start to put it into their references into these things, and then they maybe here you have to ask, is this the right question? Like, do I want because this also has to be secure, and we've been talking about it. What is the right way? That's why I go back to why I'm making this decision. So I've seen that because it's very simple, but in enterprises, in organizations, simplicity is not always the right way. You have to ask why I'm doing. Is this the right way? How can I reach? How can I scale? How can I do all of that? And if we just go back to the strict definition, why we want to scale, how we want to do it, I think we find the answer. And for me, simplicity, like have everything short, elegant, is the right answer. The separation of concerns.
So
yeah, and I would suggest, I would suggest that this is actually a hard problem, right? It's not easy, having that know-how and making sure that you're concerning and differentiating the what from the why. I would ask, our viewers to also look to the community. There's a great open source library where, we can check out what the community is thinking about skills, how are they approaching it, and use that rather than build your own, right? So I think that's something we should lead on.
Awesome. All right, let's head on over to the third question from the community. This one's from Prasad. When building a real-world AI application, how do we decide whether to use a single agent with multiple agentic skills attached to it, or a multi-agent architecture? And what are the key factors that influence this decision? Julia, would you want to take this?
This goes so much into the same conceptual ideas that we just talked about around skills, tools, and things like that. I think your default here, and I think we've actually talked about this in previous courses, your default here is start simple and get more complex as you hit boundaries. So you should start with a single agent with multiple skills and split only when you have some form of a specific problem or something along those lines that starts to force you to. Every boundary that you add adds a handoff for context. It adds latency. Failures become harder to trace. All of those things become a reality. So therefore, I would always say start simple, and this holds true kind of in all of these things. Start simple as you're learning, as you're kind of going through this process, and then go into the tools that become more complex. The key factors that I would think about here are things like the context window pressure. So again, we go into bloating of the context window and the permanent context kind of expanding, tool count and how many tools you can use in a reasonable kind of manner, and then ultimately selection accuracy for some of those tools. Usually they can use 15 to 20 tools well. The accuracy starts really to drop around 50 with most models today. So you're really starting to look at kind of all of those pieces, and those are some of the key things that I would start to look at and think about as I start to expand. But in many cases, what we're seeing in the industry today is really start simple, start with the components, and then start to break it up as you start to hit areas and boundaries. Because the more that you put into the harness and the more that you put into the structure, the more that you'll likely have to change also as the model intelligence starts to continue to grow.
I would like to add something here because I'm very passionate about this topic. In the sense, like the beauty of skills, in my point of view, is like they also came to change our mind, how we were thinking about architectures. And some architectures do not necessarily need a multi-agent. So for all of you who read the white paper, there is a beautiful organization, real life example we added there where we are discussing when multi-agents, when one agent with multiple skills. And I agree with Julia, like you have to start simple. But again, you have to question, what is this about? Because multi-agents are very good when you have parallelized things, when you have communication between agents, when you have all of this. But imagine that you have 100 SOPs, how to do something. Do you want to create one agent and then hundreds of agents? Imagine, like every time you add a new sub-agent, you have to add a new deployment, like it gets so huge. So if this is very clear, that the agent, when to use SOP1, when to use SOP2, when to use SOP3, why don't you just pass these like skills in a skill way that the agent, only one agent can do this. So you are simplifying the deployment, the agent itself, and the scalability, because like adding a new SOP is only another empty file and not another agent that is being deployed. So I think we are coming from the simplicity, but also the why. Like, do you need to ask these questions, like the parallelization, all these things where actually makes a lot of sense to have agent over skills. But I will let you read the white paper and find this example that I'm mentioning here.
I would just add one last thing to Gabriella's point, that I would totally ask this question and also ask if the flat systems are scalable. So if they are not, then we have to think about, if the flat catalogs are really scalable. So yeah, then choose routedness and in different ways.
And maybe on top of that, it's not just about when you think about scalability, also think about latency. Are you building something that is a live agent where you need to have an immediate response? Otherwise, it kind of irritates the user. Or are you building something where it can operate with a higher latency and it doesn't matter? And that becomes another really, really important distinction on what you're choosing for that architecture.
Well, thank you all. That was actually great. And also, as Gabriella pointed out, do check out the white paper. I think it does a great job giving you kind of system design ideas on when you should be, sticking with a single agent with skills framework or moving to multi-agent. And then with that said, we're going to go on to our final community question from Tinawal. How does the anti-gravity framework reconcile long-term memory with skill versioning to prevent reasoning hallucinations when an agent actually iterates on a past workflow using a newly updated skill with altered execution boundaries? Debanshu, would you want to take this?
Sure. Thank you. Appreciate the question. Actually, relying on an agent's long-term conversational memory to manage execution boundaries is an architectural anti-pattern. Speaking from experience, if you try to reconcile past memory with a version skill in the same prompt window, you're almost guaranteed to trigger rot and compounding hallucination. The white paper outlines how anti-gravity handles this actively, avoiding that reconciliation. Instead of doing reconciliation, they decouple state using DAG orchestration. These are the exact mechanics that prevent reasoning errors. Instead of letting the model rely on accumulated execution history to understand like a past workflow. The system extracts the payload from the text input. State is passed between nodes via file message bus using structured schema references. Second, when the agent needs to execute an updated workflow, it loads a capability profile. This acts as a swappable version control bundle that dictates the skills, tools, and boundaries for that specific node. Finally, to prevent the old execution boundaries from bleeding into this new logic, the orchestration layer performs a hard reset. It unloads the previous system instructions and flushes stale variables before swapping the version profile into memory. By utilizing this strict tear down and rebuild processes, the framework forces the model to execute against the constraints of the updated skill MD, rather than attempting to synthesize a hybrid from that conversational memory.
Maybe if I want to add a clarification here is, in this case, that the question, for this question, when the agent gets this wrong, it isn't hallucinated in the usual sense. It's not inventing anything. It's faithfully following a procedure that no longer exists, right? So the agent isn't wrong, but the memory is stale. The memory is the problem. So to fix this is to treat memory and skills as different things with different life cycles. Memory is episodic, what happened, when happened, etc. And skill is procedural and version, how we do it now. So if you think how we are doing now, this skill has been updated. You are like assuming this is a very outdated skill. So you know that this is the new version of this skill. This is the skill, the source of truth that you should use today, not on the memory. So the skills are the source of truth. Version and current, memory is a hint, never an instruction. Pin versions to the workflow of the state, make every boundary change visible. And one thing that is very important is fail loud. So if the agent thinks like there is a discrepancy, tell the user, look, this is the memory, this is what I'm doing it. This skill is already out of version. So make the versioning part of the agent visibility. So the agent can explain this to the user and give options how to proceed, and the user is aware. So I think this is depend regardless of anti-gravity or any framework. This thing is something that you will have when you have like memories and skills and workflows, etc. So I would recommend to follow this approach.
I love the concept of failing loud. Just to follow up on this, how Devanshu and Gabriela, how do you think about kind of backward capability, compatibility of skills, right? Like, should a V2 version of a skill always be safe to swap in with the version 1, or is that unrealistic?
If we were to think through, from a very ground up principle, I hope, that's what the case is, and unless like you're sort of coming up with like a version of skills that are not battle tested, right? And you're swapping that with like a V2 version that is battle hardened, right? I think that would create like sort of behavioral differences which you didn't have with V1, where maybe V1 was like failing under certain conditions which were not very apparent. But I would recommend to always use the latest version of the skills so that you have like that crowdsourced information that we were talking about, in the repos.
I think there is not a single right answer. What if you were having a security vulnerability in the previous skill? So obviously there is no way you want to go back to that, right? Obviously, like no way you want to go back. But what if the new version has this security vulnerability? So obviously you want to go back. So that's why I think like failing loud from the agent goes more than telling the user. It's trying to find the discrepancies. What is the difference? What does it mean actually if I move from here, here? We like, it's just like getting more explicit on what is happening between the versions. And I think this is like just code versioning. This is something we can do to that.
Perfect.
Awesome.
Thanks a lot, everyone, for your insights.
Yeah, thank you to all the guest speakers for coming on here to answer all of these questions. Really appreciate the in-depth answers that we got and all those, nice conversations that we had.
Perfect.
All right, now we're going to move on into the code labs. Today we have 2 of them, and they're actually going to take you from using a skill to building agents that use them. The first one will walk you through how skills work inside anti-gravity. The second one is where it gets really hands-on. You'll use Agent CLI together with ADK, and Polong is actually going to walk us through both of them. Over to you, Polong.
Hello, everyone. I'm Polong. I'm a DevRel lead for Cloud AI at Google, and I'm super excited to talk to you through some of the code labs today. So the first code lab, as Smitha mentioned, is on using skills, authoring skills, and installing some pre-built skills in anti-gravity. So in this first code lab, you'll see that you can create skills. And skills, as was mentioned by the folks, they're essentially just a skill.md file sitting within a folder. And it could optionally have some scripts, some references, some assets as well. And here's an example of a skill. So you would have a skill within a folder, and this skill is the database schema validator. It may have a, it definitely needs to have a skill.md file within it, along with some front matter at the top that describes the name of the skill, the description of the skill, and what the skill should actually do. So this code lab will walk you through how to create your skills in anti-gravity, the breakdown of skills, and you also learn across a different variety of skills in terms of different levels of complexity, if you will, as well. So there will be skills that you'll be using in anti-gravity, and all that it will do is just have a prompt. It's just a set of instructions of how you can run through the skill to help you with formatting your Git commits. And then you also have other skills in which you're actually going to add a little bit of determinism into your skills. Sort of as Gabriela and others had discussed, the trajectory or the evaluation of skills is a really hot topic. And so there are times in which skills will be a little bit non-deterministic because they're essentially prompts. So you may want to think about sometimes you want to enforce certain very deterministic behaviors within the skill. And the database schema validator will be an example of that, where you'll be actually calling upon a Python script to actually run as part of the flow of the skills. So this is a really interesting one to look at. And so each of these skills that you'll be learning in this first code lab will go through a different variety of different kinds of ways in which to build skills and discover how the different resources within the skill can help you add more capabilities to how the skills essentially run. You also learn a little bit more about Agent CLI, as Smitha just mentioned. This will enable you to, just using prompts, create agents in ADK that you can use to help you with process automation, or to provide agents that you can have customers or your users use directly as well. You also learn about installing agent skills directly in anti-gravity as well. And so this will make up the first code lab that you'll be going through today. And so as an example here, here is a skill. This is a markdown file. You have your front matter at the top, and then you have some of the instructions below. And in this one here, because of the deterministic behavior that you might want to have to validate a particular schema, and you always definitely want to run it in this particular way, then you might have it in a code file like in this Python script that will run as part of one of the instructions steps within this skill. Okay, and then so the next code lab is actually a deeper dive into Agent CLI and the whole agent development lifecycle with ADK. And so for those of you who joined us in the previous Kaggle 5 Days of AI with Agents course, you had authored ADK agents with code, right? This time, this code lab doesn't have code that you'll be writing. You'll be writing everything through prompts in anti-gravity using the skills and commands that are made available through Agent CLI. So you'll create a project, and then in this project, you'll be creating an agent. This is a customer support agent. And what it'll be doing is to classify if the user query is related to shipping, because it's for a shipping company. And then if it's related to shipping, answer some questions. So it'll look something like this. I've asked it, where do you ship to? Currently only ship within the United States. Okay, how can I track my order? And then it will, say, we'll send you an email to track the link. Okay, super simple. So you'll be able to create this agent just using prompts in Agent CLI with anti-gravity. And then, so I'll show you kind of like how that sort of works. So here I am in the anti-gravity IDE, and I've simply just run like one of the final commands in that code lab to test my agent, which you saw just earlier in the other screen. And what I did was it said, launch the local development playground for my customer support agent. And you'll see during the 26 seconds that it was running, it viewed the skill, the Google Agent CLI workflow skill, which is part of Agent CLI, to understand how to run or launch the local development playground. So it knows the commands it needs to run, it runs the commands, and then it launches the web interface for me to be able to actually see it in localhost, which is what you see here. So you see the sort of end-to-end journey of building agents just through prompts using Agent CLI, including linting, including testing, and command line execution as well. And then, of course, you can discover some more things that you could use with ADK. The skills that you'll be learning throughout these code labs, you can also serve inside the ADK agents themselves as well. So, you have skills that you can use as part of anti-gravity. You have skills that you can use within the agents as well. So you can think of how you could share skills across when you're vibe coding. You could create skills and even create agents just to allow other people to use those skills. So those skills could be same and common across different sort of facets and different layers as well. So I have listed a couple of bonus challenges here in addition to these 2 code labs, especially based off of this wonderful discussion from all these guest speakers here. The first one is, so as you go through these code labs, I want you all to be thinking about what are some manual, tedious tasks that you kind of have to do as part of your work or part of your studies or part of your daily life that you might want to think about automating. So repetitive, tedious things that you might want to think about automating that maybe you could convert into a skill. So the way that I would approach it is in anti-gravity, try to do things manually, and then ask anti-gravity to convert that into a skill, to create the skill for me based off of that. So, okay, so that will help you create some skills that will help you in your day-to-day life. And then the second thing, which was a really hot topic today, was on evaluation. So how do you think about evaluating the effectiveness of your skills that you've just authored? So that's going to be a big question for your particular workflows. And then finally, as Gabriela said, the why, the big why question. So making sure that your skill is solving your problem, not just making sure that the skill works as intended, but also solving your actual problems in your day-to-day lives. I think that's going to be the biggest question of all, and thinking and seeing how skills fit into that sort of larger equation. So those are my sort of soft bonus challenges to these 2 code labs. Hope you have a wonderful time with the code labs. Love to see you all in the Discord server. And that's it. So back to you, Smitha.
Thank you so much, Pulong. I highly recommend running both of those code labs end to end. You're going to learn a ton from that. And then also, if you get curious on how you can give your agent capabilities to use Google services, Google also has its own set of skills to empower your agent to do exactly that. And I'll be leaving those resources in the description box below. With that said, let's move on to the pop quiz.
Perfect. By the way, I'm just thinking skills are like macros we used to be in the olden times, like record actions and repeat them, as Pulong mentioned. So that's how I would think of them. All right, pop quiz. First question for today's pop quiz, take your pen and paper, is under the open standard defined at agentskills.io, which file must be present in every skill folder? This has been discussed already in the white paper and this live stream. Is it A, skills.md, B, config.yaml, C, run.py, or D, manifest.json? The correct answer will be shown in 3, 2, 1, and it's A, skill.md. We talked about it a lot in the white paper and this live stream. Let's move on to the next question. How does the progressive disclosure of agent skills optimize context windows? Is it through A, by loading the entire skill body scripts and assets, B, by keeping only metadata in context and loading the skills.md strictly on demand, C, by compressing all instructions into vector embeddings, or D, by using vector database similarity instead of token window? The correct answer, think about it, we discussed it a lot. Correct answer will be shown in 3, 2, 1, and it's B. We discussed it a lot. It's more about on-demand loading and routing and all of those things we discussed earlier. All right, moving on to the next question. What phenomena occurs when dumping too many static instructions into an LLM system prompt, leading to degraded performance as the input size grows? Is it A, overfitting, B, context rot, C, epistemic drift, or D, token compression? So think about it. And The correct answer will be shown in 3, 2, 1, and it's B. It's context rot. The rest do not apply. There's no drift happening. There's no ML model being trained here, and we're not definitely not compressing tokens. All right, let's move on to the next question. What is required for an agent skill to graduate to the action allowed tier? Is it A, simple peer model LLM, and the LLM is a judge eval? B, an offline run passing once? C, golden data set review and manual spot checking? Or D, full adversarial red teaming and sustained access across multiple runs, eval runs? Think about it, and the answer will be shown in 3, 2, 1, and the correct answer is D. It requires the full suite of things before it gets that access privilege. All right, to our last question. What is meant by the engineering practice of shifting intelligence left by skill design? Is it A, moving runtime logic from the LLM prompt into standard scripts? B, increasing the overall system prompt size? C, generating code before writing tests or specs? Or D, allowing the model to autonomously design the database schemas? Think about what left could mean here. All right, the correct answer will be shown in 3, 2, 1, and the correct answer is A, where you move it more towards LLM logic, more towards the scripts. All right, that brings us to the end of our pop quiz and our session. Smita, do you want to?
Yeah, awesome. Thank you, Anand. Quick wrap off before we sign off. Day 4 assignments are going to be dropping shortly, and tomorrow's topic is security and evaluation, which honestly might be the most important session of the week. We've spent 3 days giving agents more capabilities, right? Tools, interoperability, skills, memory. Tomorrow is about how you keep all of that reliable and safe in production. Another thing, keep the discussion going on in Discord. The mods are active. And also as a reminder, questions get selected from Discord and you can stand a chance to win Kaggle swag. And also get started on the code labs if you haven't already. Try writing a custom skill of one of your own and see how it changes the way your agent actually behaves. Also, if you've missed day 1 and day 2's live streams, they will all be linked in the description box below. Thank you, everyone, and see you tomorrow.
Thanks, everyone. See you tomorrow.